Let me briefly talk about the mode finder object in SLiM model. So it's pretty much the object that you need to initiate on all of the SLiM model package. To initiate, you need to put in the profile type, profile name, geometry type, geometry name, output path, input path, and xmin, xmat, like that is Toyota rotor, location z, effective menus, and suffix, mref, impurity charge. So it will just just initializing by reading all the profiles. That's initialization. Strength is a magic function that pretty much if you print the object, it won't print out a address of the object. It will print out this pretty much a parameter at the peak for this specific profile. And set x star is pretty much just a setter to set the x star, which is a spread of Gaussian function for the omega star e, so electron magnetic frequency. Q fit, this is just the polynomial fit for the Q profile. And the Q modify is pretty much you will change the object in the Q to the modified Q as such. And once you modify, you want to get back to nominal, you just need to say nominal. So everything will go back to the nominal Q profile. And the Gaussian fit GUI, that's, I don't think, unless you want to develop a GUI, another standalone GUI that require Gaussian fit, you don't necessarily need that. And another one is Gaussian fit is pretty much try to fit the Gaussian function. Another is and that's useful, maybe it will be useful. And omega e peak range, so pretty much it will pretty much return the peak and the xmin, xmax for the range of around the peak. See, this default is 1%. And rational surface, pretty much for the given toroidal mode number, it will return the location of rational surface and the corresponding ploidal mode number. And the rational surface peak, so pretty much it will give you the one that is the closest to the rational surface that is closest to the peak. And this is the top surface. Pretty much this will return the number of a rational surface closest to the peak. The default is 1. Parameter from dispersion is pretty much, if you want to calculate it manually or for some reason you want parameter, it will return all the important parameters that you need for the dispersions calculation. Good for theorist. And dispersion, this is a dispersion using the global linear kinetic theory developed by Joel Larriker. Link in the description of the GitHub repository. And it will output pretty much the growth rate and frequency based on this set of a parameter. And those are the plots. Pretty much you can plot out the Q scaling and rational surface with different color. And this just ignore that. And this one just plot out the one that is the one that you expect to be unstable as red, the one being stable as green. The rational surface. Just recall that in the GUI video, I talk about the plot Q profile, similar plot like that. Those two functions. And omega Q surface demo, pretty much this plot out the omega star E and Q profile and the rational surfaces. So that's That's similar to what you see in the SLiM mode finder GUI that plot out in the fast version, pretty much alignment rational surfaces to the peak. And this is one that including the boundary, the radial stability boundary, and this is a highlighted top percentage of omega star E. Those are pretty much the one that I need for writing the paper. Those are for demonstration purposes. It will be really messy, but for those you may need to use if you want to develop something. Honestly, those are rather easy to construct. The useful function here are those that you may find useful, especially knowing all the objects, knowing all the attributes of the object. See that R sigma. So R sigma is pretty much R over sigma. R ref is just the major radius. CS2 k hertz. So pretty much is speed of sound 2 kilohertz over kilohertz. It's a conventional convention to translate from the gene unit or other the conventional unit to kilohertz. So pretty much theory to experiment, in other words. And omega n nominal, speed of sound, gyro radius. I think this is the L ref, pretty much the minor radius for the given location of interest. X, so pretty much for us it will be in the peak. X is pretty much an array that is within our range. Pretty much radius array as a radius, and S hat nominal, eta is omega. I think is omega star T. So temperature gradient. Temperature gradient 1 over temperature gradient over 1 over density gradient. That's a conventional eta definition. Ky nominal. Ky is normalized by the rho s, which is a gyro radius. Nu in this sense here it will be collisionality over omega star n. The effective is impurity. Beta is pretty much a ratio of a magnetic pressure over pressure. Magnetic pressure over thermal pressure. Q is a safety factor, and omega star E is electron diamagnetic frequency and Doppler shift. Those are for the Toyota mode number n equals 1. For the sake of course uniformity. To make it easy to understand and change. And that's the object.